Okay, I'm going to try and walk you through the geometry review very quickly. Okay, so on the next one we have to determine if the triangles are congruent. If they are, write a congruent statement. A congruent statement means triangle ABC is congruent to triangle DEF or something like that. Okay, you got to name the triangles for a congruent statement. And then name the postulate that's used. Okay, so let's look at the first one. We can see that these two lines are parallel, and because the lines are parallel, we know that these interior angles are congruent right here, and we can already see that these angles right here are congruent, and we know by the reflexive property that this side, TS, is congruent to itself. So we have, let's see here, what do we have? We have an angle, and looky, angle, angle, side. Angle, angle, side. So by AAS, we are going to say that triangle UST is congruent. Now look at the direction I went here. I went from this first angle to here, and let me put my little congruence there. We went from the angle to the side, UST. So I've got to do it the same way on the other side. Angle to angle, oops, angle to side. So it's going to be congruent to RTS. Always make sure they match up. Your angles and your sides match up when you name your triangles. Okay, let's look at the next one. We have two right angles, so we know those are congruent. We have two sides right here that are congruent, and we can use the reflexive property for this side. So let's see what we've got. We can say that triangle RAC, so I'm going on the long side from R to the right angle to C. RAC is congruent with COR. Make sure your angles and sides match up. And that's going to be by, because this was congruent also, we're going to use HL because this is the hypotenuse and here's a leg of the triangle. Now, why can't we do something else? Because the other option is side-side angle, and we know what that means when we write it backwards. Don't want to use that. So we're using HL on that, hypotenuse and a leg. Okay, let's look at number 3. And we have an angle that's congruent. We've got a side that's congruent. Don't have any reflexive property, nothing else there, so there's no conclusion on this one. Okay, it says in triangle ABC, well, as soon as I see that, I'm going to draw it. ABC. AB is 3x plus 5. Oh man, I'm having trouble writing. Okay, I had to redo. AB is 3x plus 5, BC 2x plus 8, AC is x plus 2, and we know that angle A is congruent with angle C, which is right here. Okay, well now we know by the isosceles theorem that if you have two angles that are congruent, their opposite sides are going to be congruent as well. So in order to set this up, to find the lengths of each side, we need to take these two sides and set them equal to each other. So 3x plus 5 is going to be equal to 2x plus 8. And when you solve that out, you end up with x equals 3. And once you have x equals 3, you plug that back into each one, and you get your angles are as follows. AB Now remember, we don't use a line segment mark when we're doing a measurement. No. It's just AB is equal to 14. BC, of course, is going to be equal to 14 as well because those two sides were congruent, and AC is equal to 5. And I might add, guys, I'm going over these. You need to be trying them yourself. It doesn't do you any good to just copy what I'm doing without having worked it through. Work it through, then watch my video, okay? Number 5, find x, it says. Okay, well, let's see here. We know if this is 90 degrees, then the two remaining angles are going to add up to 90 degrees. So this angle plus this angle are going to equal 90. So we're going to set those equal to 90. 4x plus 2 plus 3x plus 4 equals 90. And when you solve that out, you find out that x equals 12. Okay, on number 6, it says find the measure of DFG. So that's this one right here we're trying to find. So we need to remember, based on exterior angles, that this exterior angle is going to be equal to the two interior angles. Okay, I was getting a little tongue-tied there. This exterior angle is equal to the sum of the two angles that are not adjacent to this one, to the non-adjacent angles. This angle right here is adjacent to this one, and I mean, think about it. These two add up to 180, and these three add up to 180. So this one is sort of the one that goes with both. So these two angles right here, these two and this one, are going to add up to the same thing. Okay, we learned that in 4.2 when we did that in your notes. So at any rate, to solve this, set this angle equal to these two. And when you do that, you get that x is equal to 3. And then when you plug it in, you're going to plug it into, I think the easiest way is to plug it into this one. And you find out when you do that, you get 120 degrees, which means that the one that we're looking for right here is 180 minus 120, which is going to be 60 degrees. Goes right in there. Okay, so in this next one it says, what do we need, okay, in order to prove these angles are congruent by side, angle, side? What other information must be given? Well, on this one we have an angle, we have a side, and so we're going to need this side right here to go in order: side, angle, side. I mean, note, if you said this side right here, we would have angle, side, side, and we know that's a bad thing. Angle, side, side, not gonna work. Okay, so you want to use this one and this one. So what we need to prove, you would need the information that line segment DO is congruent to line segment CA to be able to prove that side, angle, side. Now let's look at the next one. On this one, we have a side shown as congruent. We also know from this that these two vertical angles are be congruent. So the other side that we're going to need is this one right here, because this one, like this end side right here, that's not going to help you because that would give you side, side, angle. Doesn't work. So we need the green ones that I have on there. And so DG needs to be, I'm sorry, that's not a D, that's an O. Yeah, let's erase that. OG needs to be congruent with IG in order to make that happen. Okay, on the number 9, what do we need to make this congruent by angle, side, angle? So we have angle, angle, and so you need the included side, which is the one in between it, is this small side right here. So we need OB to be congruent to GR to make that work with angle, side, angle. Okay, let's go to the next page. Okay, on number 10 it says use the distance formula to classify this triangle MNP by its sides. So we have M, N, P. So if you're going to do the sides, you're going to have MN. You're going to have NP. Oops. And you're going to have MP. So what I did was I put each of the coordinate pairs that I was going to use for each of these 4, 5 and 4, 2 for this first one. For the second one, you need 4, 2 and -5, 2. On the third one, you need 4, 5 and then -5, 2. And to use the distance formula, remember our little acronym we used was senior, miss, PMS, and that's to remind you that it's square root, and we have parentheses, we have a minus and a squared, plus a minus and a squared, so this is x2 minus x1, y2 minus y1. So you're just plugging in your x's and your y's. Make sure you, let me use a different color for the y's. X, y. Make sure you always do y minus y and x minus x when you are doing your distance formula. So if you go through all of that, you will find out that MN equals, and we should write it like this without the line on top of it when we're doing a measurement, is 3. NP is equal to 9. And MP is equal to the square root of 13. So we're to classify this based on its size. Well, if one side is 3, one is 9, and one is the square root of 13, all three sides are different, so that means it's a scalene triangle. And since I mentioned scalene, is it possible to have a right triangle be a scalene triangle? Yes or no? That would be yes, because you can have a right triangle that has 3 different sides. Just thought I'd throw that in there. It's scalene, but it's also right. There you go. Okay, it says find the measurement of R if triangle PQR is congruent with STU. Now I'm going to make STU exactly in the same order that I did PQR. Make sure everything matches up. And then plug in what P is. The measurement of angle P is 3x plus 21. S is 4x plus 16. And then Q is 7x plus 5. So let's think this out. We eventually want to get this measurement here, but to solve for x, since these two triangles are congruent, we know that P is congruent with S. So we can use that to find x. We can say 3x plus 21 is equal to 4x plus 16. You solve that out, and you find out that x equals 5. Then once you know that, you can plug 5 into P and into Q, get the measurement of those two angles, and then subtract from 180. And when you do that, you find out that Q is equal to, I should put measurement of angle Q is 40. The measurement of angle P is equal to 36. And when you take 180 minus 76, you find out that the measurement of angle R is equal to 104 degrees. Okay, on number 12, it says the measurement of the angles are represented by the 3 different measurements. So to solve this one, add them all up, set it equal to 180, so you get 24x plus 12 equals 180. You solve that out, you get x equals 7. You plug in 7 to the 3 different expressions, and you get 63 degrees, 48 degrees, and 69 degrees. Okay, on to number 13. Okay, on number 13, it says that this line segment here, AE, is congruent with DE, and that angle EBC, which is this little one right here, is congruent with ECB, which is this one. And we're supposed to prove that this line segment AB is congruent with this one here. So let's think about how we could do that. So we have these 2 line segments that are congruent. We can also prove that this angle right here is congruent with that one by all vertical angles. And then we can also state, using our theorem for isosceles triangles, since this angle of this little bottom triangle, if these 2 angles are congruent, then we know their opposite sides are congruent as well. So this side is congruent with that one. So look at what we need to do in our proof. We have our givens, and then we need to prove that these 2 angles are congruent by vertical angles, all vertical angles congruent, and we need to prove that this side is congruent with this one. If 2 angles in a triangle are congruent, then opposite sides are congruent. Okay, well, I'm making that pretty messy, so let's clear that up, and let's go ahead and write it out. AE is congruent with DE, given. Angle EBC is congruent with angle ECB, given. Now, at that point, with this, because we have this down, now we can say that line segment EB is congruent with EC, and our reason is, remember, your reason always has to be above the statement that you have. So here's our reason right here. If 2 angles in one triangle are congruent, then opposite sides are congruent as well. Okay, now let's see what else we can do. We can say that angle AEB is congruent with angle DEC. That's these angles right here. And that's all vertical angles are congruent. Now we can go ahead and declare, because we had this as given, remember? And then we added in this because of the congruent angles when their opposite sides are congruent. So now we can declare that triangle AEB, and make sure you do these in the correct order, is congruent with triangle DEC. So I went from A long side down to E to B. So D long side down to E and then C. by SAS, side angle side. And let's see if we can find that side angle on side. Here's a side. Here's the angles that are congruent. And here's the other side that's congruent. And so finally we say line segment AB is congruent with line segment DC. How do I know that? CPCTC. Because once we've declared these two triangles congruent, all their corresponding parts are congruent. Okay, let's go on to the back page. Okay, we're given that BFE is congruent with BDE, so there's that angle right here, and that BE bisects this angle, FBD. Well, if it bisects that angle, then we know that these two angles are going to be congruent. We can prove that. And then we can prove that this side is congruent with itself. Let's use green. And so we have an angle, and a side. So that should be enough to prove what we need. Because once we do that, we can use CPCTC to show that these two sides are congruent. And then once we do that, we can say that E is the midpoint of FD. So let's go ahead and write it out. Okay, so here is the proof. I tried to put those statements that kind of go together in the same color. So angle BFE congruent to BDE given. BE bisects angle FBD given. So therefore, angle FBE is congruent with DBE, definition of angle bisector. BE congruent to BE, reflexive property. Triangle FBE is congruent with triangle DBE by AAS. And let's find that angle on side. Here's an angle. Here is an angle. And here's a side right there. Now, once that's done, FE is congruent to ED by CPCTC. And once we've proved that these two are congruent, then we can say E is the midpoint of FD, definition of a midpoint. Okay, let's look at number 15 and kind of map out a plan with it. Since angle DAE is right angle, so I'm going to put that in. CBE is right angle. And so we know those two are congruent. All right angles are congruent. AD is congruent with CB. So AD and CB. And E is the midpoint of AB. So knowing that, we can go ahead and prove that these two are congruent. And so that should be enough for us to prove by side, angle, side, that the two triangles are congruent. And then once we've done that, we can use CPCTC to declare that angle ADE and angle BCE are congruent. So I'll write that out for you here. Okay, so here's your proof written out for you. First I gave you the two right angles given, and then declare those all right angles are congruent. Then the next two givens, AD is congruent to CB, and then E is the midpoint of AB. And because of that, I know that AE is congruent to BE. And now we have enough by SAS. Let's look here. Here's the angle, and here's one of the sides, and here's the other side. But even though that kind of spells a bad word down the side, we can still see that it goes side, and then angle, and then side. So it's done the right way. And then finally, declare the other two angles congruent using CPCTC. Okay, there's just a couple other little things I want to go over. So watch. Suppose I tell you that ABC is congruent with DE, or no, that I have two triangles, ABC and DEF. And I tell you that, okay, so let's write them down, ABC, and do DEF in the exact same way that you did ABC, always in the same order. If I tell you that AB is congruent to DE, and that angle AE, sorry, that would be angle ACB is congruent with angle DFE, and I tell you that DF is congruent with AC, what do we know? Can we tell, are these two triangles congruent or not? Let's see what we can do. AB is congruent with DE, so let's mark that. Angle ACB is congruent with DFE, mark that. And DF is congruent with AC. Do I have enough to declare these two triangles congruent? No, because we have a side, and we have an angle. Always go in order, side, side, angle. Not enough because, bad word, doesn't work. Okay, suppose I give you these two triangles and I tell you that KM is congruent with PR. And then I tell you that angle KLM and angle PQR are right angles, which I already had those marked in there for you, but let's just say I give you those two things, the right angles and that KM is congruent with PR. Is that enough to tell us anything about these triangles? Well, no, not really, because all we have is a hypotenuse and an angle. We would need at least another leg right here. So we could do hypotenuse leg. Or if we had this one and this one, these two, we could do side, angle, side, something like that. But as stated at the beginning, there wasn't enough information to prove anything. That would be no conclusion. Now, I want to remind you from your quiz, because a lot of you got some things wrong on this. Let's say I have triangle KLM and triangle PQR. If I say line segment KM, what is it congruent to? It's going to be line segment, what? If you have the K here and the M here, it's going to be P and R. If I say angle LMK, what's it congruent to? Well, just do the letters in the same order. LMK is going to be QRP. Angle QRP. So always do them the same way. And then, I guess finally, just a reminder that scalene triangles, no congruent sides. They're all different. Isosceles have two sides that are congruent, and their opposite angles are also congruent. You could have a right triangle that's isosceles, but you cannot have a right triangle that's, oh no wait, take that back. You cannot have a right triangle that's equilateral, because you have equilateral and equiangular are going to be the same, and if a right triangle has a 90-degree angle, there's no way that you're going to have three angles that are the same on a right triangle. But you could have one that is isosceles and right at the same time. You could have obtuse triangle that's isosceles. Could you have an acute triangle that's isosceles? Yes. You could have one like that. Can you have, is an equilateral triangle and isosceles triangle? Is it? Well, yes, it has at least two sides that are the same. It just happens to have three. Remember our little Venn diagram? Isosceles triangles, equilateral triangles. They're a subset. So equilateral triangles can be isosceles, but not all isosceles are going to be equilateral. I think I'm going to stop there. It's 30 minutes. Okay? Good luck on the test. See you tomorrow.